Chapter 4, Section 6 in the 7th grade note-taking guide is entitled Metric Measurements. So in the top part here, they're going to start off the same way they did when we were talking about U.S. measurements, and they're going to ask us to identify appropriate units for each measurement here. So let's go ahead and take a look at the benchmarks. Now the problem is, once again, these are not given to us in the note-taking guide, so we want to refer to the textbook where they've given these to us. The nice thing is we don't really have to guess too much about these because they've either got to have meter, liter, or gram in them because that's what the metric system is all about. So they start off with the meter measures. Meters are, of course, a measure of length. And they give us millimeter, which is about the thickness of a dime. So if we were looking at a coin, we would not be looking at a coin going across this way, but we would actually be looking at the coin that way. How thick that coin is about a millimeter. If we're talking about a centimeter, that's about the width of my little finger. So if we were looking at my little finger going this way, not up and down this way, across from left to right is about a millimeter. A meter is about the width of a doorway, and most of you have seen a meter stick, so we have some familiarity there. And then a kilometer is about the length of 10 football fields. That's up there with miles. You want to think about it that way. If you look at car speedometer, in America we use miles per hour, but almost everywhere else you go, even just over the border into Canada, it's measured in kilometers per hour. Mass is a measure that's associated with grams, how much something weighs. We have a milligram, which is the mass of a grain of sand. So if I had one individual speck of sand on my finger, that would be a milligram. When we're talking about that there, think of medication. If you've ever looked at a Tylenol or an aspirin, those are usually measured in milligrams. That's how many of those little specks of sand might be potent in those pills there. Gram is the mass of a small paper clip. So if I held one paper clip in my hand, that would be approximately a gram. And a kilogram is the mass of a textbook. So if I was holding my math textbook in my hand, not my workbook, my textbook in my hand, that's going to be close to a kilogram. Capacity. Capacity is measured in liters. Milliliter is the amount of liquid in an eyedropper. Very small measurements again here. If you just held one eyedropper full of liquid, that's a milliliter. Liter, well, we've all bought bottles of Coke, so we know what a liter looks like. That's the amount of water in a large water bottle. And a kiloliter is the capacity of 2 large refrigerators. So picture filling your refrigerator up with water. That's going to be a couple of those would be a kiloliter. So very large quantity. So with that in mind, now we should have a better chance here of solving question 1. The amount of water a runner drinks each day. Well, we even said it's how much is in a water bottle. So liter makes sense there for the answer. Probably a couple, as a matter of fact. Liter is going to be the measure for how much of water a person drinks because it's how much is in a water bottle. Length of a boat. You could make a case for centimeters here, although it would be very hard to measure with centimeters. Meters is probably the most logical answer there. If we think of a meter stick, which again we've probably all seen here, we could measure a boat, a regular fishing boat perhaps, with a meter stick probably pretty easily. 4, 5, 6 meter sticks and work from front to the back of the boat. And then the mass of a car. The mass of a car, that's going to be best in kilograms. Remember, a milligram is 1 speck of sand, so you're going to need a lot of those to measure or be equal to a car. Gram is a paper clip, so you're even going to need a lot of those to come up with something equal to a car. So kilograms is about the only thing that makes sense there. Now, here we go now. They're going to have us actually start converting in the metric system here. And they're going to try and approach this a different way than we're going to because they try and teach you a lot of multiplication and division techniques to do this. And converting in the metric system is a lot easier than that because the metric system revolves around the number 10. And because it revolves around the number 10, all we have to do to convert is really move a decimal. So as long as you know how the metric prefixes line up, you can do this. So here, is a list of the metric prefixes in order from biggest to smallest. Now, after each one of these, of course, we would append whatever measure we're talking about, meter, liter, or gram. But here, kilo starts the list off. So that means anything kilo is the biggest unit I can come up with that's on this list. So a kilometer or a kiloliter or a kilogram. All right, then the next one is hecto, so hectometer, hectoliter, hectogram, then deca, and then the unit. Yes, this is actually a spot on the chart for whether it's just regular old meter, regular old liter, or regular old gram. Then we have deci. Now we're getting towards the small side, decimeter, deciliter, decigram. Then centa and milli is the smallest. All you have to do when you're looking at these conversion questions is figure out where you're starting and where you're going on this chart, count how many jumps and in what direction that's going to move me, and then move the decimal the exact same way in the number part, and that will convert the number into where I want to go. For instance, if I want to convert deciliters to centiliters, I'm going to go from deca to centa, which is one jump to the right on the chart. So if it was 10 deciliters, right, since I moved one jump to the right on the chart, I'm going to take the number 10 and jump the decimal one time to the right. Well, when I do that, it becomes 100. So 10 deciliters is 100 centiliters. And that's it. All right, no T-charts like yesterday, no complicated multiplication, division, figuring out how to fill out a chart. It's just moving a decimal. So if we look at number 1 here, 530 centiliters to liters, well, to go from centiliters to liters, I'm making 2 jumps to the left on my chart. So I'm going to go ahead and move 2 jumps to the left with the decimal here. So if I look at 530 and jump the decimal 2 times to the left, remember if we don't see anything, it's like it's at the end, it becomes 5.3, as in 5.3 liters. That's it. 530 centiliters is 5.3 liters. You're done. No division like they're doing here. No remembering how I'm going to multiply here. I'm just going to move the decimal 2 places to the left like they say right there. And that's my conversion. All right, so let's look at the next one here. Elizabeth buys a pumpkin that has a mass of 3 kilograms and another that has a mass of 2,150 grams. Which pumpkin has the greater mass? How much bigger is it? So we want to convert here these all into kilograms or all into grams to make a comparison. That's going to be the easiest thing for us to do. So what they've decided to do here is convert this into kilograms to do this here. So that means this 3 kilogram pumpkin that Elizabeth has, the first one anyway, she's not going to touch that. But this 2,150 gram one, we're going to convert that into kilograms. So if we look at our chart here, we're going from grams to kilograms. We'll go from grams to kilograms. That means I'm starting here, and I'm going to go to here. Grams to kilograms. So that's 1, 2, 3 jumps to the left of my chart. So I'm going to take my number and move my decimal 3 times to the left on the chart. So if I take 2150 and move it 3 times to the left, 1, 2, 3 times to the left, I end up with 2.15, as you see, 2.15 kilograms. Well, now let's compare them. One is 3 kilograms, the other one is 2.15 kilograms. Well, what's the difference? Because that's what they want to know. Which pumpkin is bigger, and how much bigger is it? Well, 3 kilograms is obviously bigger, and when we do a little bit of subtraction, 3 minus 2.15 changes into 0.85. So that kilogram is 0.85 kilograms larger than the other. Pretty easy. All right, so let's look at the questions at the bottom here. Number 1, the amount of water in a kitchen sink. And they want to know what's the most appropriate metric unit for the measurement. Justify our answer. So if we look back at that chart again, we've got milliliter, liter, and kiloliter to choose from. Well, if I'm filling a sink up with eyedroppers, that's probably going to be a painful experience, so it's probably not that one. Kiloliter is how much is in 2 large refrigerators, which is obviously way more than a sink. So kiloliter probably isn't the best measure either. So by process of elimination, liter is probably the best answer. A few large water bottles is easily going to fill up a kitchen sink. So liters is going to be the best unit of measure to approximate the amount of water in a kitchen sink. Number 2, in the final question here, we're converting 580 grams to centigrams. Well, to convert from gram to centigram, I'm on my chart here. I'm going from where it says unit for gram to centigram, which is out here, which is 1, 2 jumps to the right on the chart. So since it's 2 jumps to the right on the chart, I'm going to take and move my decimal 2 times to the right. So take 580 and go 2 times to the right. Well, both those jumps are empty, so they're going to fill in with zeros. So that's going to be 58,000 centigrams. And that's it.